Very good morning to everyone, and today we are going to see the first program on MPMC, that is Microcontroller Laboratory Model. And the first program, what we are going to see is 8051 programming. So what we are going to see is 8051 program using assembly language. This is ASM indicates assembly language. The first program what we are going to see is the program for the program for 8-bit addition, and we'll be looking over the subtraction, multiplication and division. So these are the very basic program. We are going to look it over through 8051 assembly language mode. So as we have already seen about the assembly language, so the basic component is the mnemonics. That is, we'll be writing an instruction for every program. So basically to perform an 8-bit addition, we need two 8-bit numbers. So in order to store these two 8-bit numbers, we need two different locations, so that we are going to use we can get the numbers by different manners, such as storing the numbers in a particular location. We can retrieve from the particular location. Otherwise, we can directly load the value into the operand through immediate addressing mode, or we can directly load the value from the direct memory location. That is can be done by using direct addressing mode. And also we can get the value from the location, and there the location of the actual value will be loaded. So that is called as indirect addressing. There are three different methods to retrieve a numbers. Indirect addressing. So these are the three methods. We'll be getting the values from the particular memory location of a particular controller. So in 8051 controller, we are having a internal RAM and ROM memory. So we are going to get the value from a particular directly loaded into the memory location. That is why we are going to see about the immediate addition. That is through immediate addressing, we are going to get the immediate addressing. So the first basic thing is we are going to load the value to the accumulator. So for that we can use the code MOV, that is a move. For example, let us take a 15 value, that is the immediate value has to load up to the accumulator. That is the value is going to move from the immediate value is directly loaded to the accumulator from that is the left to right. The move instruction tells moving the value, that is the immediate value, the hash symbol indicates the immediate value will be loaded into the accumulator. So once the value has been loaded into the accumulator, next we are going to directly we know that there is an instruction called add C, that is the add with the carry. So add with the carry can load the immediate value and perform the addition between the A and the immediate value. So let me write the instruction ADDC, that is the addition with carry with accumulator with the immediate value. So now what is happen means the accumulator will get the value of A, the A actually holding the value of 15 plus your 20, that is the immediate value will be loaded. So here you must know that the basic numbering system that is happening inside the program, that is actually we'll be writing the hexadecimal addresses over here. So for each and every address, this value will be loaded. So these values are all denoted in the hexadecimal format. Unless you have been indicated with the decimal or some other octal kind of a format or binary format, it won't be get reflected inside the controller. So by default it will be in the hexadecimal format. So now the addition is performed. The A is having the value, but we cannot know that we cannot retrieve the value and make it visible to the user that the value that is being stored in the A. So we are going to fix a particular location in the memory. So to move the value that is being loaded into the accumulator to the particular location. For that we can write the program. We have to load a particular address location. The address location in a 80-bit controller is a 16-bit address location. So that we need a help of a 16-bit registers. So we are going to use the move dptr, that is a data pointer we are going to use. It is a 16-bit address pointer, so that we can load the immediate value of 4150. So now 4150 is loaded into the dptr. So next what we are going to use here, where you need to move the value that is the accumulator to the dptr. So for that we are going to use index addressing move, that is a move x, because the value will be loaded in the external memory. So need to be loaded into the external memory. Move x a at dptr comma a. So that's all. The value will be now loaded into the 4150 location, that is a 20 plus 15. The value will be 35, will be loaded into this particular dptr. So next we are going to see we need to stop the program at here. So I'm going to use the label, that is a here is my label, because I don't know what address that is being available here. So the here and then sjmp, that is a short jump here, so that I'm fixing the controller should not move to the next location. So that we'll be getting we have performed the simple addition from this basic code. So let us look into the actual simulation by using the KEIL software, how this program is getting worked. So once you have opened the KEIL, it will be loaded with the already loaded project. So now I'm going to show you what are the tabs that is being available and what you have to do when you open the KEIL program. So this is the actual tabs that is being available. For in that particular tab you need to select a project. So when you are selecting the project, that is a new Microvision project, so a pop-up window will open where we need to store this particular project. I'm going to store it in the desktop. So this is my basic addition program. I'm going to create an addition project file. So this is the basic window that will open to select the target device, because the KEIL is an IDE that is used that has both a compiler and debugger, and we can also directly connect with the controller and upload the program. So that we need to select what is the target device that actually we are going to work. So we are going to work on 8051 board. So we need to select which is the appropriate manufacturer that we are going to use. There are a lot many manufacturers for different version of the program. So here I'm going to use the microchip version. Second, let me check. Microchip. In that we are going to select the 89C51. So this is the specification of the controller what we have chosen. I'm going to select OK. So this is a basic target file, that is a target project has been created, and the source group there will be a startup A51 has been loaded. So now I'm going to create an assembly language program. So for that you can select by using file new, or there is a icon that is a control N can be used to create a sample document. So I have already stored the program, so I'm just copying the program. So in this program you will be you will be looking over what is the thing that has been added as a org, that is the initial level of the memory from where the program has to start, because there will be a certain code that will be loaded in the certain program memory, and we need to select only the user accessible memory. So while getting the controller from the data sheet, you must know what is the user accessible memory that we can able to load. So here it is an IDE. I have chosen org that 000h is the initial origin address, and at last I have added the end to know the compiler, to make the compiler to know that this is the end of the particular program. So I'm going to save this program as add.asm. So the ASM indicates that it is an assembly language program. So once that is being saved, there is a color change will be there to indicate which are the variable and which are the mnemonics, and which are the immediate values that will be indicated over here. So once it is being done, you need to add this file to the source group. So by clicking the right click option, add new item to the group source, you need to select the already loaded value. You can directly add a new file, or you can add the existing file to the source group and add ASM. So I have added the add file. So once it is being added, it will be loaded into the project group. So and then we can get close this and then select this add, and initially you need to translate this code to the basically we have written an assembly language. You need to translate this and build according to the target device. So and then we can go with the, you can check over what is the memory units and what are the errors in the particular program. I'm going to select the debug option over here. Once you have selected the debug option, there will be a pop-up. So once you have clicked the debug option, you will be getting a new panel of debugging, disassembly, and register pair and commands and a call stack, local variables. So everything will be getting visible. So once it is being visible, you can click the run to execute your code what you have written. So before executing the code, you can see what is the actual default value that is being available at the different register, and the A register, B register, and the data pointer you can able to see over here. So let us see once we have turned on the run, and let's wait for a few seconds as there is no the code is being executed, and then we can stop running the code. So once you have stopped running the code, you will be looking over that the accumulator stores the value of 35, that is the result of your addition program, and the data pointer is loaded with the 4150. So once you have looked over to the memory location in your controller, the 4150 location, you will be getting the value of 35 value that is being loaded into the 4150. So this is the basic program that is being executed to perform addition between two 8-bit numbers. So you can also perform the two 16-bit numbers with a different addressing mode that can be possible with this KEIL software, and also you can write your code on your own. So there are a lot of tutorials that is being available on internet. You can look it over and perform different codes for different application. So that's all for this addition program. Next we'll be looking over the subtraction program on the next video. Thank you all.